Hello everyone. Welcome to Aviation Engineering YouTube channel. All right, today I'm going to take another lesson. This is part 4 regarding AT chapter 21. So this is Boeing 777 level 3 type training lesson series. Okay. All right. So if you wish to take your type training for 777, please go to the approved organization 147 approved type training organization and get your training done, and then get your endorsement in your EASA license. All right. Okay, so let's go to these lessons. The previous lessons in part 4 I did it is very long, and now I think you please watch those series in right way, then you will have a good idea. All right. Okay, so let's go to the lesson. All right, so today I'm going to teach you ATA chapter 21 air conditioning system part 4. Under this lesson I'm going to teach cooling and temperature control, and the last one trim air pressure regulation and shut off control. All right. Okay, so let's go to the content, and in this one under cooling I will explain you like operations, air synoptic display and air conditioning maintenance page, and the ground test. And on second one temperature control, under these introductions, control, general descriptions and mechanical and the interfaces. And the last third one, the trim air pressure regulations and shut off control. Under this I'm going to explain about the introductions, trim air pressure pressure shut off valve, and trim air pressure sensors and the functional description. All right. Okay, so let's go to the first one, cooling. All right. So the operation. So this guide explains how the pilot control the air conditioning airplane's air conditioning system, called normally we call this as a PACS. All right. So now let's see, where are the controls? Where are the controls for the PACS? All right. The air conditioning control panel is located on the P5 overhead panel. Okay. In the cockpit, they have an overhead panel. So the air conditioning control panel is located on the P5 overhead panel, the panel on the ceiling above the pilot in the cockpit. So on this panel, you will find the left pack and the right pack switches. They have two switches for the left and the right. Okay, I keep, you see this kind of thing. So left pack, this is one switch, and this is the R pack, it means right pack. So, and the air conditioning reset, it means aircon reset switches. Okay, you can find the aircon reset switches. All right, so how do the pack switches work? How do the pack switches work? Right, so the L pack and the R pack, it means the left side pack and the right side pack switches turn the cooling system on and off. Remember, L pack and the R pack switches turn on the cooling system on and off. They work like toggle switches. Okay, they work like a toggle switches. So in the auto mode, when you push the switch in, it shows auto. Right, when you push the switch in, it shows auto. This means the computer automatically control the air conditioning for you. All right, so in the off light, when the switch says off, it doesn't just mean the button is pushed out. Okay, so it means that the actual valves that let air into the systems are fully closed. All right, so let's see, it is an important note that the off light needs electricity to turn on. Okay, the off light needs electricity to turn on. If the plane loses power on its main electrical lines, it means main electrical buses, AC buses, the off light will not shine. Okay, it means if the plane loses power on its main electrical lines, the off lights will not shine even if the system is actually off. Okay, to off lights needs electricity. It means to illuminate the off light, there should be a electricity. Okay, all right, so now see, how do you fix a system failure? How do we fix a system failure? All right, if the air conditioning system stop working or fails, pilot use the air condition reset switches. Okay, remember, if the air conditioning system stop working or fails, the pilot use the aircon reset switch. Okay, you can, here is the reset switch. So this is a spring loaded button. Okay, this is a spring loaded button. You press it and it springs right back out. Okay, so pressing it restart the system after breakdown to try and get the air flown again. Okay. All right. Okay, you can see the air conditioning panel. This is located in the P508 panel. See this one. You can see flight deck temperature. You can adjust. Okay, it put to the auto and cabin temperature. Okay, you can see recirculation fans upper and lower. They have two recirculation fans. Okay, so this is aircon reset. Okay, and this is less pack and R pack. These are the trim air left and right. All right. Okay, now let's go to the 1.2 air synoptic display and air conditioning maintenance page. All right. Yeah, this is the air synoptic display and air conditioning maintenance page. Okay, you can see this one. All right. Okay, let's learn about this. So air synoptic display, the pilot screen. So the air synoptic display is a visual screen in the cockpit that helps pilots quickly check the status of the air conditioning packs, the cooling system using colors and symbol. Okay, the air synoptic display is a visual screen in the cockpit that helps pilot quickly check the status of the air conditioning packs. Okay, these are they have several colors so before, right? So you can see the pack status symbols come from green oval, the pack is turned on and working normally, and white oval, the pack is turned off, the system cannot read the data, and the amber oval with an X letter, this pack has failed, and the green flow bars, these lines shows that air is successfully moving through the system. Okay. All right. Now let's go to the standby cooling message. Standby cooling message and adversary message. An adversary message like standby cooling or pack mode left or right will pop up if the pack is running but has one of these three specific problems. Okay. If there's one of these specific problems, this adversary message will pop up. What are these specific problems? They are the air cycle machine failed. Okay, the air cycle machine failed means the main cooling machines will be failed, and the both temperature sensors at the condenser inlet failed. Okay, both temperature sensors at the condenser inlet failed, and next one, the economic cooling valve. If one of these is happen, then the advisory message pop out like standby cooling or pack mode left or right. So note, if the pack completely stops running, if the packs completely stop running, the standby cooling message will stay on the screen. Okay. All right. So now let's go to the air conditioning maintenance page, the mechanic screen. We call it as mechanic screen. So why the mechanics or engineers, they use this page. So this page displays highly detailed measurements for the mechanics or engineers, right? So like a temperature rule, all temperatures on this page are shown in degrees Celsius. Okay, so let's go system flows and pressures. System flows and pressures. All right, so let's see the flow schedule. Shows the system target settings numbered 0 to 4. The left and right packs usually run on the same schedule. And the pack flow like volume, how much air volume is moving measured in cubic feet per minute. And the pack flow mass, the actual weight of the air moving measured in pounds per minute. Okay, and the pack in pressure, the air pressure entering the packs, and the trim air pressure, the pressure difference between the cabin and the trim air system. Okay, these are the okay, these are the things we use, we can see in this maintenance page. And next, go to the temperature checkpoints. Where is the heat? Temperature checkpoints, it means like where is the heat. So the system tracks temperature at various stages of the cooling process. So let's see mixed manifold temperature, the temperature where different air sources mix together, and the pack out temperature, temperature out of the air as it exits the cooling packs, and the primary heat exchanger in out temperature, temperature going in and out of the primary heat exchanger, the first rate, we call as first radiator. Okay, and the next one, secondary heat exchanger out temperature, temperature leaving the secondary heat exchanger, like second, we call it as second radiator. Next one, the compressor out temperature, temperature leaving the compressor, condenser in temperature, temperature entering the condenser, the moisture remover, and the TG2 turbine in temperature, temperature entering the second turbine. All right, let's go the valve positions. It means like, are they open or closed? Valve position, we need to check, are they open or closed? So let's see, the mechanics can check if the system's mechanical doors and valves are working. So the pack control CS shows computer channel A or B is currently controlled. It means pack control channel. Let's see the shows which computer channel A or B is currently controlling the cabin temperature. They have two channels, right? A and B. Let's control later. So let's learn about later. So low limit valves position, turbine bypass valve positions. Okay, we talk this about the low limit valve positions and the bypass valve in the previous lessons. Okay, in detail. So shows how open these valves are. 0.00 means completely closed and 1 means completely open. So Ramya inlets, the outside air scoop for the specific control, 0.00 means open and 1.00 means closed. So econ control, lower flow, upper flow valves. So simple indicators that shows whether these specific valves are open or closed. All right. Okay, you can see this one, right? Pack standby cooling message is coming, and here is the cross, like pack status symbol. Okay, okay, not working, and green bars is normally working here. All right, and here's the maintenance page, right? You can see the pack flow volume. In the left is this one, right is this one. Okay, you can see the pack control channels, number one, number two, A or B, right? So the pack in pressure is showing. All right, so you can see icon cool valve is closed. Okay, you can see the all the these are the things in the maintenance page. Okay, about the valves. Okay, we discussed DC valve positions and the temperature checkpoints and also the system flow and pressures. All right, synoptic page. Okay, now let's go to the ground test. So what are cooling ground tests? What are cooling ground tests, right? When mechanics use the onboard computer to test cabin temperature control system, they can choose the three main type of test of both the left and right of the plane. Okay, when mechanics use the onboard computers, we are using onboard computers to test cabin temperature control system. They can choose from three main type of test for both left and right side of the plane. So these are pack actuator test, and the second one system air on test and system air off test. Remember, what are they? Pack actuators test, pack actuators test, system air on test and system air off test. All right, so these tests ensure that the airplane's temperature computers can properly talk to and control different line replacement units. Okay, so which is just aviation speak for parts. So line replacement units, we call it as for the aviation, like for parts and components. Okay. All right, so mechanics run these tests during three specific situations, right? Mechanics run these tests during three specific situations: a full system test, a routing operational test, and or after a part of swapped out line replacement unit test. Okay, so mechanics can run these tests during three specific situations. What are these three specific situations? Full system test, routing operational test, and or after a part is swapped out. Okay, like replace if a part is swapped out, we have to do the line replacement unit replacement test. All right, so let's go to the pack actuators test. First one, pack actuators test. Right, so this test check if the computer can control the mechanical moving parts, actuators inside the cooling pack. Okay, pack actuators test. From this test, what we test, this test checks if the computer can control the mechanical movement parts, actuators inside the cooling pack. Okay, so what is test? Ramya inlet door. In this test, we will test Ramya inlet doors, the scoop that lets outside air in, and the turbine bypass valve and the low limit valve. Okay, there are three things we can move mechanically moving. Okay, the pack actuator says what we check, the mechanical movement is properly working or not. What are these? The Ramya inlet doors is working or not, and the turbine bypass valve working or not, and also low limit valve. So what happened during the test? The cooling pack stops running normally. The cooling pack stops running normally, and the RAM air doors will physically move back and forth to, so the computer can check them. Computer can check them. All right. So how long it takes? It takes about 35 minutes. All right. All right. Now let's go to the system air on test. The second one, system air on test. The first one is turbine test and actuator test, and the next one, system air on test. So in this test, check if the computer can properly control the air conditioning parts while while the PAX system is stimulated as being on. It checks a wider range of valves and the main cooling machine. Okay, so this test checks if the computer can properly control the air conditioning parts while the PAX system is simulated as being on. It checks a wider range of valves and the main cooling meshes. Okay, so what it tests? Okay, in system air on test, what is test? They test upper and lower flow control valves and the economy cooling valves and air cycle machines, the main cooling engine, and the trim air pressure regulation and shut off valves. Okay, control hot air used to fine tune turbine cabin temperature. Okay, so what happens during test? Normal pack operations stop and the ram air doors will move. Okay, in this test, normal pack operation stops and the ram air doors will move. So how long does it take? This is a very fast test, takes only about 5 to 10 minutes, written as 510 minutes in the original technical manual due to a missing hyphen. So let's go next one, the system air off test. So this test checks if the computer can safely shut down and control components when the air is simulated as being off. It also checks the trim air system on that specific site. Okay, remember in this state what they test in this test checks if the computer can safely shut everything down and control components when the air is simulated as being off. It also checks the trim air system on that specific site. All right, so what is test? They test ram air inlet door, turbine bypass valve, and low limit valve, and the trim air system components on that side. All right, so what happens during the test? Both the cooling packs and the trim air system stops running completely. Okay, what happens during test? Both the cooling pack and the trim air system stop running completely and the ram air doors move. Okay, ram air doors moves. How long does it take? This is the quickest test, take only 2 to 3 minutes. Okay, there are 3 tests. What are they? Pack actuator test and the system air on test, and the last one, system air off test. Okay, all right. Okay, these are the cooling ground test. Okay, you can see system test shows the operational line replacement test are similar. These are the air conditioning cooling test. Okay, these are the air conditioning. You can see select system test, left pack actuator, system air on, system air off, left trim air system. Okay, for the right also same. Right, see the other ground test. All right, let's go. This is a table from, it's like a summary. So test name, pack actuators, main pass text, ram doors, bypass valve, low limit valve from the pack actuators, length around 35 minutes. And what happens? Pack stops, ram doors moves. And the next one, system air on test. What are the things we check? Lower upper valves and econ valve, air cycle machine, trim air valve is around 5 to 10 minutes. And what happens? Pack stops, ram doors moves. And the test name, the last one, system air off test. What the things we checks? Ram doors, bypass, low limit valves and trim system around 2 to 3 minutes. What happened? Pack and trim stops, ram doors moves. Okay, this is like a summary. All right, so now let's go to the second one, temperature control. Yeah. Okay. So what is the purpose of the system? What is the purpose of this system? Right. So yeah, the primary job of the temperature control system is to keep the air comfortable for everyone on board. Okay, so it controls the flight temperature in 2 main areas. What are they? They control the temperature in the 2 main areas, in the flight deck and the passenger cabin. Okay, the flight deck, the cockpit where the pilots sit, and the passenger cabin are the where the passengers sit. All right. Okay, so what is the secondary job? Secondary job is setting targets. It tells the main cooling units, the packs, exactly what temperature the air needs to be, and the managing the APU when the airplane is on ground or flight and get its air from the APU, auxiliary power unit, the small engine in the tail. This system calculates exactly how much air the packs needs to take from it. All right. Okay. So the two main part of the system. There are two main parts to do its job. The temperature control system is split into two smaller specialized systems. What are they? A, the zone temperature control and indication. B, the trim air pressure regulation and shut-off control. All right. So the zone temperature and control and indication. Zone temperature control and indication. What it does? All right. This part monitors the actual temperature in different sections like zones of the cockpit and cabin and adjust them to match the temperature the crew has selected. Okay. So what the zone temperature control and indication did, okay, what they do, what it does, this part monitors the actual temperatures in different sections. It means different zones of the cockpit and the cabin and adjust them to match the temperature the crew has selected. Okay. And second one, trim air pressure regulation shut off control. What it does? It does trim air is hot. Trim air is hot. High pressure air used to fine tune the temperature in different zones. This part of the system manages that hot air. It safely adjusts, monitor and send distributes the air pressure down the line to the individual temperature valves. Okay. All right. So this is the diagram. You can see this is the temperature control. Is go to the zone temperature control and indication, and then is go to the trim air pressure regulation and shut off control. All right. So let's go to the next one, the control. Okay. Second one, under temperature is control. Right. The brains of the system. Okay, what is the brain of the system? Is the cabin temperature control. That is the brain of the air conditioning system. Right. So the cabin temperature controls are the main computers that control the system. They adjust valves to mix hot and cold air, ensuring the cockpit and passenger areas stay at the exact temperature selected by the crew. Right. So where are the controls located? Pilots use the air conditioning panel on the P5 overhead panel ceiling of the cockpit, and the flight attendants use the screen in the passenger cabin called cabin system control panel. Okay, the flight attendant, they use the screen in the passenger cabin called the cabin system control panel and the cabin area control panels. Right. So safety smart feature like this system talks to the galley lavatory vent fans. If both vent fans turn off, the computer stops trusting the cabin temperature sensors and switches to a backup control method so the sensors don't miscalculate. All right. So managing the hot air trim air controls. Managing that hot air trim air controls. Right. Trim air is high pressure hot air taken from the engine. Trim air is the high pressure hot air they taken from the engine. Okay. This is taken from the engine. And it is injected into the cold air stream to warm things up when a zone gets too chilly. Okay. If there's too much chill, I mean too much cool, what they do, they take the trim air and mix with the air and distribute it. Right. So pressure control, a pressure regulation and shut off valve keep this hot air at a steady, safe pressure. And the sensors, a pressure sensor monitors the air ducts and the reports back to the cabin temperature controller computer. And the backup, if the main cabin temperature controller computer fails to control this valve, a backup computer called SCPC takes over. Okay. I don't remember the name of this one. Okay. All right. Okay, now let's go to the settings, the temperature zone control. Like for the pilot's cockpit, pilots use the flight deck temperature knob to direct set the target temperature of the cockpit. Okay, normally the pilots, they use the flight deck temperature knob to direct the target temperature of the cockpit, and they also use the cabin temperature knob to set the master temperature for the entire passenger cabin. Temperature limits, the absolute limits allowed by the systems are the 18 Celsius to 29 Celsius. For the flight attendants cabin, attendants can fine tune their specific cabin areas using their wall panels. Okay, wall panels they can use. Okay, right. They can adjust their local area up to 6 Celsius warmer or cooler. I mean, they can adjust their local area up to 6 Celsius warmer or cooler than the master temperature the pilot set. Right. Example, if the pilot set the master cabin temperature is 22 Celsius, the flight attendant can adjust their specific section anywhere between 80 Celsius and 28 Celsius. It will never let them go past the absolute system limits. Okay, like this, between 6 Celsius. Okay. All right. So keeping the computer informed to make sure the system is working perfectly, the cabin temperature controller relies on constant updates. Right. So let's see the sensors. It uses zone air sensors to check how the room feels. The duct sensors to check the temperature of the air blowing out of the vents. Okay, it uses zone air sensors and also duct sensors. So talking to the APU. So when the airplane is on the ground, using the tail engine APU for air conditioning, means in the aircraft is on the ground, they use the APU air. Okay, for the air conditioning, the cabin temperature controller calculates exactly how much air is needs. It sends an APU demand signal to APU computer telling it to the throttle up or down to provide the perfect amount of airflow. All right, so this is the general description control. You can see the left system shown, right similar. Okay, you can see the zone duct temperature sensors over there, zone air temperature sensors. This is the control indication by left cabin temperature controller. Okay, flight deck manual controls. Okay, trim air pressure. You can see trim air pressure regulating and shut off valve, trim air modulating valves here. Okay, you can see this is the off command, trim shut off out, stall warnings, pack flow schedules for. Okay, this is lavatory vent fan status and temperature selection, temperature indications over there. These are the signals goes, right? Okay, this is the miscellaneous switching panels. P5 is here. Okay, this is the main panel, air conditioning panel P5. Okay, so this is the general description about controlling the air conditioning. Okay. All right, so let's go to the general description, mechanical 2.3, a trim air pressure regulation and shut off control. Trim air pressure regulation and shut off control, right? Trim air. Trim air is highly pressurized or taken from the trim. What are the trim air? Trim air is the air. These are very highly pressurized air is taken from the engine. Because it is naturally too hot and powerful, its pressure must be strictly managed before it's entered to the cabin areas. Because why is highly pressurized air is tapped from the engine. Okay. All right. Okay, so the valves. There is a separate trim air valve for the left side and the right side of the airplane. Separate valves. So the pressure rule, these valves keep the trim air pressure between 2 and 8.5 psi higher than the pressure inside the cabin. Okay, the pressure rule is these valves keep the trim air pressure between 2 and 8.5 psi higher than the pressure inside the cabin. All right. Though the sweet spot is the system usually aims for exactly 5 psi above cabin pressure. This gives the perfect balance. It is strong enough to push the air through the pipes and quiet enough so passengers don't hear loud air noise. So when monitoring, pressure sensors constantly measure this air and report the number back to the temperature computers. Okay, right. Zone temperature control. How hot and cold air mix? Right. So the airplane's main air conditioning units, the packs, generate cold air. To get the perfect temperature for different areas, the system mixes the cold air with the hot trim air using what valves? Modulating valves. Okay, valves that can open little, a lot, or close complete. These are the modulating valves. Okay, they mix hot and cold air by using modulating valves. Right? How? How the air mixes? The passenger cabin zone, cold air from the central storage area called the mix manifold is sent towards the cabin. The system inject hot trim air directly to this system to warm it up and desired temperature. Okay, the passenger cabin zone, how it's mixed. cold air from the central storage area called the mix manifold. Okay, the cold air from the mix manifold is sent towards the cabin, and the system injects hot trim air directly into the stream to warm up at to the desired temperature. Okay, now let's see the flight deck cockpit. The cockpit is kept completely separate for safety and comfort. Hot trim air is for the pilot, mixes directly with cold air coming straight from the left back. Remember, for the flight decks, it's the cold air coming straight from the left back for the cockpit. Okay, and this is directly mixed with the trim air. Okay, just remember that is for the safety. Okay, controlling the temperature for more heat. If a zone feels too cold, the modulating valves open wider to let more hot trim air in. And the less heat, if zone is too warm, the valves pinches shut to let less hot air in, letting the cold air dominate. So feedback, the computer stays smart by checking two types of sensors in every area. The zone air temperature sensors measures how warm actual room feels, and the zone duct temperature sensors measures the temperature of the air currently blowing out of the vents. Okay. All right, so this is the general description of mechanical way. Okay, you can just go through. This is the pneumatic system. This is the flow control and shut off valves. These are the flow control and shut off valves. This is the left pack. Okay, and this is the trim air pressure regulating and shut off valves here. And these are the mix manifold. The mix manifold here. Okay, ground air connectors. Okay, normally this is the right pack. Okay, the air is mixed, and then you can see the zone trim air modulating valves. Okay, this is are the zone trim air modulating valves. If this is, if let's say if this area is too cold, E section is too cold, and then this valve is little bit open and the hot air mix with this one, and the this area will be a little bit cold. Okay, so this is the way how they control the temperature inside the zones. Okay, all right. Now let's go to the interfaces, right? What is an interface? What is an interface, right? An interface is simply how different systems of the airplane talk to each other, right? The cabin temperature controller, the main temperature computer uses two different methods to communicate. Okay, so first one is the digital network. They use ARINC 629 buses. It means high-speed digital highways used to send complex data back and forth between computers. These are called digital networks. They use ARINC 629 data buses. And next one, analog signals, direct electrical connections used to move physical parts, valves, or read simple sensors. They use two different methods to communicate. What are they? Digital networks and analog signals. Digital networks, they use ARINC 629 buses. Okay, right. So the digital interface, the ARINC 629 networks. The cabin temperature controller computer connects to the airplane's digital networks to share information with these major systems, right? So AIMS, Airplane Information Management System, they connect like cabin temperature control computer, cabin temperature control computer, they connect with the major systems in the aircraft by using ARINC 629 networks, data buses. Okay, what are these systems? AIMS, Airplane Information Management System. For what? The central maintenance computer. It handles ground testing, cockpit display messages, and fault monitoring when something breaks. And the second one, air ground system, AGS, tells the temperature control computer whether the airplane is flying in the air or parked on the ground. And next one, CSS, cabin service system, transmit the specific temperature selected by the flight attendants on their cabin panel. And the APUC, APU controller, the tail engine computer, the cabin temperature controller sends an APU demand signals here to ask for exact amount of air needed for cooling and ventilation. And the ECS, MCS, ECS miscellaneous cards monitors the bathroom, lavatory, and galley kitchen exhaust fans to tell the cabin temperature controller if they are running or off, running or off. And the ASCPC, air supply cabin pressure controller, air supply cabin pressure controller shares flight data like how high the plane is flying, altitude, and the engine stall conditions, and how much air volume is required, flow schedules. And next one, overhead panel, OPS means overhead panel system, connects the physical knob and buttons to the cockpit ceilings to the cabin temperature controller. This includes pilot temperature selectors, trim air switches, and air conditioning reset button. All right, so let's go to these are the before are the digital interfaces, and next one analog interfaces, direct electrical control. For mechanical parts and basic sensors, the cabin temperature controller doesn't use the digital network. Instead, it uses direct electrical wire. So outboard signals, what the cabin temperature controller controls, the computer sends direct electrical currents to physical move these valves. The trim air pressure regulating and shut off valves to control the hot air, the main hot air pressure, and the zone trim air modulating valves mixes the hot air into individual. So these the analog interfaces they are using for the trim air pressure regulating shut off valves, zone trim air modulating valves, and the digital one interfaces like they connect with the main systems, major systems in the aircraft like airplane information management system, air ground system, cabin services, and the APU controllers, etc. Okay, right. So inbound signals, what are the what the CTC reads, cabin temperature controls reads, right? The computer reads direct electrical data coming back from the sensors. These are the rotary variable differential transformers. These are the position sensors attached to the valves that tells the computer exactly how wide open or close the valves door in decrease. And the zone temperature sensors measures the actual room temperature in the cabin and cockpit, and the zone duct temperature sensors measures the temperature of the air blowing out of the vents, and the trim air pressure sensors measures the air pressure inside the supply pipes. Okay. All right, so these are the interfaces. Okay, you can see AIMS, AGS, CMS, APU demands, and lateral galley fans. Okay, these are systems connected through the ARINC 629 data buses, but the direct one, okay, direct controlling for the for what direct analog interfaces. Direct one is controller for the trim air pressure regulating and shut off valves, and so on trim air modulating valves. Okay. Okay, you can go through it, this one, right? Yeah. This is the left cabin temperature controller. Okay, air conditioning panel is here. Okay. All right. Just go through this one. Okay. These are the analog signals. Okay. These are the analog signals. You can see these are the, this line shows the analog signal. This line shows the, what are the system array 6 to 9 buses. Okay. All right. Okay, now let's go to the trim air pressure regulating and shut off control. All right, so introductions, what is the purpose of this system? Okay, so the trim air pressure system has three main jobs for the airplane's hot trim air. What are these? Adjust, monitors, and distributes. Adjust, monitors, and distribute, right? So adjust means the pressure, adjust the pressure so it is safe to use, and monitors the system for leaks and breaks, and distributes the hot air down the line to individual zone valves, right? So managing the pressure. The main temperature controller computer is responsible for controlling the system. Okay, what is the thing responsible for controlling the system is the main temperature control computer. Okay, right. So the goal is it adjusts a part called the trim air pressure shut-off valve. The goal, okay, managing the pressure, the main temperature computer is responsible for controlling the system. The goal is it adjusts a part called trim air pressure shut-off valve, pressure regulating shut-off valves to keep. All right, so managing the pressure, the main temperature controller is responsible for controlling the system. The goal, it adjusts the part called the trim air pressure regulating shut-off valves to keep the hot air pressure between 2 and 8.5 psi higher than the cabin pressure. And the target is normally aims for exactly 5 psi above cabin pressure to keep the system working efficiently and quietly. Okay, where does it get cabin pressure data? Where does it get cabin pressure data? To know what the cabin pressure is, the system looks at the source. The first one, primary source is air supply cabin pressure controller computer. Okay, primary source is Okay, where does it get cabin pressure data? Where does it get cabin pressure data? It knows what the cabin pressure in the system look at these sources. Okay, what are the cabin pressure data is taken from the primary source is air supply cabin pressure control computer. It also act as a backup system to safely shut off the pressure regulating shut off valves if needed. And the backup source is a remote cabin pressure sensor takes over if the primary computer fails. All right. Okay. All right. Cockpit controls and warning lights. Right. The pilots manage this system using switches on the overhead panel. Okay. On, pushed in, the system is running normally, and off, pushed out, the trim air system is turned completely off. All right. When does the fault light and crew message turn on? So an amber fall light on the switch turn on and a trim air left or right warning message pops up on the pilot screen if any of these three problems happen. I talked in the beginning, right? So what are these? Overheat, they are inside the zone duct, get dangerously hot, and the turn off, the pilots manually push the switch to the out off position, and the component failure, the computer detects a broken part like a failed on pressure regulating shut-off valves, a bad computer, or a broken pressure sensor. Okay, so an amber fault lights will I means like there is a amber fault lights on, and also trim air left or right warning message pops out on the pilot screen if the overheat or turn off or computer failure. Component or overheat means the air inside the zone duct gets dangerously hot, and if the pilots manually push the switch to the out, it means off position. And component failure, the computer detects a broken part like failed pressure regulating shut-off valves and bad computer broken pressure sensor. At this time there is a fault light is switch on, and also trim air LOR warning message pops out on the pilot screen. Right, so the location of the components, where are the parts? If a mechanics needs to fix this system, they have to open up the ECS bay. Okay, if the mechanics needs to fix this system, they have to open up the environmental control system compartment underneath the aircraft floor. So inside each bay, they will find trim air pressure regulating shut-off valves. Inside the each bay, you can find trim air pressure regulating shut-off valves, the main valves that control the airflow, and the trim air pressure sensor located on the keel beam, the structure spine of the plane just forward in front of the pressure regulating shut-off valve. Okay. All right. So yeah, let's see. This is the ECS bay. Okay, this is the ECS bay. These are ECS bay is the bay have the packs. Okay, so this is the trim air pressure sensor is here, and the trim air supply duct is here, and here's the trim air pressure shut off valve. Okay, these are the ozone converters, right? So if something happened, they need to open the ECS bay and they need to go to check the sensor and the pressure regulating shut off valves. Okay, you can see this is the left system carrying 6 to 9 buses. These are signals come from here, and the control indication byte off commands cabin pressure, right? So this is the trim air pressure regulating shut off valve. Okay, trim air pressure sensor here. Okay, this is the ozone converter. This is upper FCV and lower FCV flow control valve. Okay, these are the two flow controls valve. Okay, this is the trim air pressure shut off valve. Flow control valve is the one who used to mix the air. All right. Okay. Okay, now let's go to the trim air pressure regulating shut off valve. Trim air pressure regulating shut off valve. That's right. What is the trim air pressure regulating shut off valve? The pressure regulating shut off valve, pressure regulating and shut off valve is dual purpose mechanical valve. That is the dual purpose mechanical valve. The main temperature controller uses it. Okay, normally this is a dual purpose mechanical valve, and it is used to shut off the hot trim air completely when needed and regulate or control the air pressure heading down the pipes and act as a backup temperature regulator if other parts fail. This is act as a backup temperature regulator if other parts fail. So where it is located? There is a left and right valve. There are two pressure regulating shut off valve, each one for left and right. Okay, so there is a left and right valve located inside the ECS bay. environmental control system base underneath the cabin floor, right next to the keel beam. The airplane structure spine mechanics open the ECS access doors underneath the plane to reach there. Physical description the parts. The valve is electrically controlled. This pressure regulating shut-off valve is electrically controlled but pneumatically operated. Okay, what is electrically controlled means by the computer signals, and the pneumatically operated uses the high pressure of the air inside the pipes to physically move itself. Okay, and it is made up of these key parts. They are made up of these key parts. What are they? Valve body and disc, the main pipe and the internal metal disc. Butterfly valve, inside have a butterfly valve that twist to block the airflow, block or allow airflow. And the pneumatic actuator is there, the air powered piston that pushes the valve disc open or close, and torque motor is there, and electrical parts that precisely adjust the air pressure pushing on the actuator, and the shut-off solenoid, a backup electrical switch used for the valve close, and the clocking crank and position indicator, a manual handle that shows if the valve is open or closed and allows mechanics to lock it by hand. Okay, all right. Okay, how it works. Okay, how it works. The valve balances two different air pressures to move the internal disc. Okay, the valve balances two different air pressures to move the internal disc. To close, the normal air pressure from the supply pipe constantly pushes the closed side of the actuator. And to open, the computer send electrically to the torque motor. Okay, computer send electricity to the torque motor, which direct control air pressure to push to the open side of the actuator, overpowering the closing pressure. Okay, we can see. Okay, this is the one. Okay, where this is a valve disc, body valve. Okay, this is the shut off solenoids, and this is torque motor. Okay, if to close it, what we said, to open it, we send electrical signals to the torque motor, then the torque motor run and open. Okay, and the close, normally it's closed by the normal air pressure. Okay, right, to close it is closed by the normal air pressure, and to open we need to send electrical signals to the torque motor to close it. Okay, all right, this is the pneumatic actuator is there. This is the locking crank position indicator, and this is the shut off solenoid, and this is the torque motor, and here is the locking plug stopped, and the plug and filter also there. Okay, right, the fail-safe safety rule. This valve does not have a mechanical spring inside to pull it open or close. Okay, this valve don't have any mechanical spring inside to pull it open or close. Instead, it relies on the fail-safe of design. Right, so if the airplane completely lost electrical power, the torque motor shut off. Okay, if the airplane completely lost electrical power, the torque motor will shut off. When the torque motor shut off, when the torque motor shuts off, it automatically releases vanes the air pressure holding the valve open. Okay, when the torque motor shut off, what happened? It automatically release the air pressure holding the valve open. When natural air pressure in the pipe immediately pushed the actuator to close position. Okay, at this time, if the what happened, if the torque motor is shut off, at this time the natural air pressure in the pipe immediately push the actuator to the close position. This prevents dangerous unregulated hot air from filling the system during power loss. Okay, so the backup shut off, the solenoid, when the main computer cabin temperature controller uses the torque motor to smoothly open and close the valve. Okay, torque motor is the one we use to smoothly open or close the valve. The secondary backup computer uses shut off solenoid as an emergency kill switch. Okay, normally the main computer uses torque motor to open or close smoothly the valve, but in the secondary backup computer, like secondary backup computer ACPC, uses shut off solenoid as an emergency kill switch. Right, normal flight, no voltage or zero voltage, the solenoid stays relaxed and let the torque motor control the valve normally. And the emergency shut off, 28 volt DC applied to the solenoid. The backup computer sent 28 volts of the electricity to the solenoid. The solenoid instantly blocked the opening air pressure and vent it, forcing the valve to slam closed. Okay, now do you understand what happened, right? Torque motor is the one normally precisely they open or close to regulate the air. But in emergency situations, it means the emergency situation, what will happen? The secondary, okay, the backup valve or secondary valve, it uses a solenoid to completely stop the air pressure or vents coming into there, because if maybe the very hot air will go to the packs, then it can fail, so something happen inside the cabin. Okay, right. Okay, so the manual lockout for the mechanics: if the valve is broken and cannot be fixed immediately, the mechanics can legally deactivate it for safety before flights. Okay, there's a manual lockout also. It means if there's a problem inside the a problem inside this pressure regulating shut-off valve, then we cannot fix it immediately. What they do is they use the manual lockout to legally deactivate this component for safety before flight, right? So mechanics can use the locking crank. There's a locking crank, so mechanic can use the locking crank to physically force the valve into closed positions. Okay, this valve we can physically force to closed position. They then the unscrew the locking plug from its storage spot and insert into the crank to lock it in place. Removing this plug automatically when any remaining air pressure ensure the valves cannot accidentally blow open under high pressure during flight. Okay, all right, so this is the valve I talk about. Okay, they have so many things. You can see the locking crank, what this is used for, manually close the valve. Okay, the solenoid is as a secondary, is like an emergency shut off valve. Okay, for solenoid we use normally the solenoid is working under ACPC. This one has 28 voltage, and normally torque motor is the one is usually used to smoothly open and close the valve inside the valve disc, inside this pressure regulating valve. Okay, all right. Okay, that's all for this trim air pressure regulating shut off valve. Okay, now let's go to the trim air pressure sensor. Right, purpose it, what is its job? The trim air pressure sensor has one simple but critical job. It is very simple, but this is critical job. It constantly measures the air pressure right after the air passes through the main regulating valve. Okay, what trim air pressure sensor is done? It constantly measures the air pressure right after the air passes through the main regulating valve. So it reports this number back to the main temperature computer, so the system knows if the air pressure is too high or too low or exactly where it needs to be. Right. Physical depression, what does it look like? It is a small solid state electronic device, and it does not sit directly inside the hot air pipe. Instead, it mounts safely next to it and connects to the main air duct using small narrow air pressure line to sample the air pressure. Alright, location where it's found. The sensor is located in the ECS bay. The sensor also located in the ECS bay underneath the cabin floor. It is mounted directly to the keel beam, the structure backbone of the airplane. Next, right next to the trim air pressure pressure regulating shut-off valves, it is monitored. Okay, so this is the place trim air pressure regulating valve located. Okay, here it's look like trim air pressure sensor is this is the place trim air pressure sensor is located, and it's look like here the electrical connector, and this is the air connector. Okay, and here is the air cycle machines. You can see trim air supply duct here, right? Okay. Yeah, so now next one, functional descriptions, how the main computer cabin temperature controller controls the system. Like the left cabin temperature controller is the main brain. Left one is the main brain. It collects data from the all over the plane to decide exactly how much to open or close trim air pressure regulating valve, the main hot air valve, right? Left one. So when will valve open? Right. For safety, the valve is normally closed. Okay, trim air regulating valves normally close for safety, because if it is open, very high temperature will come to the cabin and have a big problem, right? So for safety, it will only open if every single one of these rule is met, right? So air is on, at least one air conditioning pack is running, and next one, not too high demand, the system is not set to full blasting power, flow schedule 4, and flying safely, The airplane is not in an aerodynamic stall and switch is on. The pilot pushed the trim air switch in and sensors work. The pressure sensors is healthy and working and the computer works. The cabin temperature controller computer itself is functioning and no overheat. None of the air ducts are dangerously hot. If any one of all of these are incorrect in right conditions, then only the pressure regulating valve can be opened. Right. So the smart pressure adjustments, the usual settings, the computer aims to keep the pipes pressure at 5 psi above cabin pressure. Okay, 5 psi above cabin pressure. The adjustment, the computer can adjust this up or down between 2 to 8.5 psi if a zone valve breaks or gets stuck open. Okay, right. So what happens during an overheat? The firewall, if the air inside the duct hits 88 Celsius, it is dangerously hot. Okay, if the air inside a duct hits 88 Celsius, is very dangerously hot. The computer immediately slammed the pressure shutoff regulating shutoff valves to protect the plane. Right, there are two ways the valve lockdown. Passenger cabin overheat. The valve latches closed. Latch means it stays locked shut like a tripped circuit breaker. It will not turn back on automatically even after it's cooled down. The pilot has to manually hit the aircon reset button to unlock it. Remember, the flight deck cockpit overheat. This has a smart safety feature to prevent the pilots from losing temperature control accidentally. If the cooling packed air is cool under 71 Celsius, the valve latches closed, locked. If the cooling packed air is already very hot, 71 Celsius or more, the valve closes temporarily but does not latch. Valve closes temporarily but does not latch. Once the air cools down, it turns back on itself. Okay. Right, so backup control, the ASCPC emergency switch. Right, a secondary computer called ASCPC act like a safety guard. It can override the main computer and force the hot air valve to close immediately in two situations. First one, the pilot turn it off, the trim air switch is pushed out, and the second one, stall conditions. If the airplane enters a stall, the engines need all available power. Shutting down the valve drops the load on the engines. Note, the stall shutdown has a strict 8-second timer. After 8 seconds, the air system turns back on automatically. Okay. All right. So the pre-flight self-test monitoring check. Right after the engine startup, the backup computer ASCPC performs a mandatory test to ensure it can successfully shut down the valves in an emergency. Okay, every time. So ASCPC send a signal to open the valves fully. Then test its ability to take control and shut them down. The entire test takes about 15 seconds. And once it passes, ACPC hands control back to the main computer for normal flight operations. Okay. All right. So this is the functional descriptions. You can just go through it. Okay. This is the things we talk before slides. Okay. All right. Yeah, that is the end of this lesson. Thank you for participating in these sessions. I think you got to know about well about the cooling and the pressure regulating valve and the temperature control under this lesson. And we have so many lessons regarding ITA chapter 21. You have to know all these things, especially Boeing 777. All right, so if you think this lesson series is good, and please subscribe my channel, Aviation Engineering YouTube channel, and also share these videos with your friends and relatives, anyone who like to learn about Boeing 777 aircraft. And also reminder for you, if you wish to do the Boeing 777 type training, please take these notes as a like a refresher training for you guys, and please go through approved training school to get your proper certificates. All right. Okay, thank you very much again, and see you on next lesson. Have a good day.